Hi everybody, my name is Tori Earle and I am an Extension Specialist for 4-H Youth Development with the University of Kentucky's College of Agriculture, Food and Environment Cooperative Extension Service. The following segment is designed to give you a visual instruction on one of this year's segments of the 4-H National STEM Challenge Galactic Quest. In our first segment of the experiment called Stellar Optics, you're going to learn a little bit about how telescopes work, how light works, and how telescopes use lenses to help bring things into closer focus that are further away. In this experiment, your participants will get to build their own telescope, and they can either use it outside or there are constellation cards in your kit that you can set up across the room. 30 to 50 feet away works best, and they can focus in on those, and it gives them the opportunity to not only describe but draw the constellations that they're seeing through their telescope. As we get into building the telescope, we'll go through that kind of step by step. But we're also going to talk a little bit about how light can play optical illusions on your eyes. So let's get started. With stellar optics, you're going to talk a lot about how light reacts to different things, especially lenses. And for the first part of that, you're going to need a cup of water and a pencil. Now, I would suggest if you're going to reuse things over and over again, that you get a cheap mechanical pencil, because they would not absorb the water like wooden pencils would. And you're going to need a cup of water. Now, you may have done this experiment or you may have noticed it in the past, but today we're going to talk about how an optical illusion, how as light passes through an object, this cup with the water in it, it's going to make things look a little differently. And in order to do it, it's very simple. You just take the mechanical pencil, or a pencil if that's what you're using, put it into the water, and you're going to be able to see, I'm going to try to zoom in a little bit here so you can take a look at it, how as the light passes through and you look at it, the pencil appears to be broken. So what is happening there, it's an optical illusion. It's the way the light waves bend as they travel in and back out to your eye through the water and through the cup. As you would do this part of the experiment, the facilitator guide gives you some guiding questions, and you might even ask your participants, what do you think makes this happen? So that brings us into the second part of the experiment, which is building our own telescope and then seeing how it works. The Stellar Optics telescope is going to come packaged like this. Everything you need will be in here, and what I have laid out here are the components to the telescope, so we can walk through and talk about the assembly of each one. Now, the most important part of the telescope itself is the lens. And these lenses, we will have two of them. The first one is a convex lens, and this convex lens is bowed out on one side and it has a somewhat flat side on the other. This is important because this will determine how you put it in your telescope. And then you will have just a flat lens like this that will be, this is your eyepiece lens. The smaller lens is your eyepiece. The larger lens is your objective lens. It goes in the opposite end of the telescope. Now they will come packed in a piece of tissue paper like this. So when you pull this out, don't throw the tissue paper away, because that's what your lenses are in. Then you have the different components of the telescope. The youth guide actually gives you a little bigger picture for how to assemble the telescope, but there's just a few little tricks to it. The stickers that go on your telescope, my recommendation is to put them on before you assemble the telescope, because once you assemble it, it's a little harder to get them on. You'll peel the paper off the back, and I would start at the center of the sticker and wrap it around on both of these. The center on the one with the 4H clovers on it is for the smaller tube. The one with the planets on it is for the larger tube. And the planets are the center of the one for the larger tube. The area in the middle between the 4H clovers is the center for the smaller tube. After you would get your stickers on your two telescope tubes, you take your convex lens, which is the one with the bow on one side, flat on the other. Place the convex lens inside the eyepiece with the convex part, the bowed part, on the side that would be toward your eye. Then the small lock ring you would place inside that, make sure it's centered. Then you take your smaller tube and you would place it down inside the eyepiece. I would set it on the table, pressing it flat in there, and make sure it's flush, make sure that it fits well inside there, like so. Then this ring will be a locking ring to put your smaller tube inside your larger tube, and you have another small fitting that will fit inside your smaller tube, like so. Set this aside. It's your larger tube and the end cap with your objective lens, which is solid and flat. You'll slide it down or drop it down inside the end cap. Then you will take this insert, which has a small circle in it and a lip around the outside. Put it inside your larger tube, pressing it in. Then you would press that down into your objective lens. Slide this together. Put in your locking ring, and this gives you your telescope. An actual fully assembled telescope looks like this, and you pull it in and out, and sometimes the stickers don't stick as well as they should, so you might have to press them down again. But what the purpose of this sliding in and out is to serve as your focus for your telescope. So as you would look through it from the eyepiece at what you're looking at through the objective, at about 30 feet is the shortest distance that I have been able to get something to focus at. The facilitator guide recommends about 50 feet to set up to use your constellation cards, which are right here. These constellation cards have different constellations on one side, and then on the other side it gives you the description of them and what the original spotters of these constellations saw in them. So your constellation cards look like this, and then on the back they have the description of the constellation and what it's supposed to look like.